Today, we have an incredible discovery to share with you brought to us by the James Webb Space Telescope. An international team of astronomers has just announced the discovery of the oldest and most distant galaxies ever observed, dating back to just 300 million years after the Big Bang. This groundbreaking finding marks a significant milestone in our understanding of the early universe. These discoveries were made by the JWST Advanced Deep Extragalactic Survey team. Leading the observations that unveiled these galaxies is Daniel Eisenstein from the Center for Astrophysics, Harvard and Smithsonian, along with his colleagues Ben Johnson, Philip Cargile, and Harvard PhD student Seheo Wu, who all played pivotal roles. As the universe expands, the light from distant galaxies stretches into longer wavelengths. For these two galaxies, this redshift effect is so extreme that their ultraviolet light shifts into the infrared wavelengths visible only to JWST. Since light takes time to travel, observing these distant galaxies is like looking back in time. The two record-breaking galaxies are named JADES, GS, Z14-0 and JADES, GS, Z14-1, with JADES, GS, Z14-0 being the more distant of the two. Not only is JADES, GS, Z14-0 setting a new distance record, but its size and brightness are also astonishing. The combination of extreme brightness and the fact that young stars are driving this luminosity makes JADES, GS, Z14-0 the most striking evidence yet of the rapid formation of massive galaxies in the early universe. Evidence of these surprisingly powerful early galaxies emerged even in the first JWST images and has been growing ever since. This trend defies the expectations most astronomers had about galaxy formation before JWST was launched. When the JADES team first noticed JADES, GS, Z14-0 about a year ago, it was a puzzle because it appeared so close to a foreground galaxy in the sky that the team wasn't sure they weren't neighbors. But in October 2023, the JADES team conducted even deeper imaging using JWST's near-infrared camera, focusing on isolating the oldest galaxies with specialized filters. The galaxy lies in an area where the JWST's mid-infrared instrument conducted ultra-deep observations. Its brightness in mid-infrared wavelengths signals the presence of emissions from hydrogen and even oxygen atoms in the early universe. Encouraged by this, the team then obtained spectra for each galaxy, confirming that JADES, GS, Z14-0 is indeed a record-breaking galaxy and that the fainter candidate, JADES, GS, Z14-1, is nearly as distant. This incredible discovery opens up new frontiers in our understanding of the universe's infancy and showcases the unmatched capabilities of the James Webb Space Telescope.